All servers in the dodSON software core library distributed programming framework example follow the same pattern. They are created using a component management component manager and built into a console application. Each server has its own directory, providing it with a configuration file from where it instantiates a component manager and provided directories to find packages, install packages, and store data. We will start by examining the relay server. The relay server is responsible for coordinating communication between the other servers. The relay server is the hub in a star network topology so the other servers can communicate. The relay server does not host any extensions or plugins. Looking at the relay server's code, we first see console UI boilerplate code. This boilerplate code creates a simple-to-consume console application user interface requiring that the software developer only add key presses, user interface prompts, and actions to be invoked when the specified key is pressed. The fixed configuration method is a text replacement function. It will get the root path, the bridge network type, and the network port value, and do a simple text replacement within the relay server's configuration file with the values that were provided. In this example, it has already been done, so we will not be invoking this method. We will, however, be invoking the start server method. The start server method first asks where the root path for the configuration file can be found. It will load the configuration file, deserialize it, and instantiate a new service manager from that configuration. The service manager facilitates the remote access and control of a component manager. The most important thing to know about the service manager is that the service manager's configuration file contains a component manager configuration. See the dodSON core library help file for more information about service managers. Once the service manager has been instantiated, the start server method will attempt to start the service manager. Internally, this will instantiate and start a component manager. Once started, the method will state that the relay server has started and loop until the user presses the escape key, displaying all the connected clients along with some basic network statistics. Once the escape key is pressed, the method will stop the service manager, which will also stop the component manager, and wait for the user to press any key to allow the user to see the results before terminating the console application. The registration server, the note server, and the RESTful service server all follow the exact same pattern. Let us look at the configuration files for the various servers. We will start with the relay server configuration. The relay server's configuration file contains a configuration for the dodSON core service management service manager. The service manager facilitates the management of remote component managers, their controllers, and components. To learn more about service managers, see the dodSON software core library help file. The service manager contains a configuration for a component manager. The component manager contains configuration subgroups for a communication controller, a component controller, folder access, installation settings, and an installer, a log controller, and a package provider. The communication controller configuration defines the types for the server and the clients, the server channel information, and a transport controller configuration. The transport controller configuration contains a registration controller, which itself contains a challenge controller, and a transport configuration, which contains the information used when transporting envelopes between servers and clients. See the Programming with the dodSON Core Networking Namespace video for more information about networking. The component controller contains the file name of the custom configuration file and the serializer type used to serialize and deserialize the custom configuration file. The custom configuration file is a second configuration file which can be used by the developer to create more configuration information. It is a fully supported object with read and write functionality for both packages and installed packages built into the component controller. The folder access items defines a set of named directories, making it possible to find specific paths by using keys. The installer contains the file name of the package configuration file and the serializer type used to serialize and deserialize the package configuration file, and the directory to install packages. The installation settings define how to install packages. See the Programming with the dodSON Core Packaging and dodSON Core Installation Namespaces video and the dodSON Core Library Help file for more information about creating and installing packages. The log controller defines a file store used to archive log, the actual log, and a group of log controller settings which defines how the log controller will behave. See the Programming with the dodSON Core Logging Namespace video for more information about logging. The package provider contains the name of the package configuration file and the serializer type used to serialize and deserialize the package configuration file, and a package file store provider type which is used to access packages in the package file store. It also defines the file store where the packages are stored. See the Programming with the dodSON Core Packaging and dodSON Core Installation Namespaces video for more information about packaging. We will use this configuration to instantiate a new instance of the dodSON Core Component Management Component Manager for the Relay server. See the Programming with the dodSON Core Configuration Namespace video for more information about creating configurations and instantiating types from configurations. The registration server, the note server, and the RESTful service server all follow the same basic pattern, with variations in the communication channel information and the internal communication modes, and the addition of a log splitter with several log filters to separate system logs and service logs. Looking at the custom configuration file for the registration service, we see that it defines a registration provider group item. This item defines which group below will be instantiated and used as the registration data source. There are two services provided: a file registration provider, which stores registration information in a comma-separated values file, and an SQLite database registration provider, which stores registration information in an SQLite database. Being able to define and instantiate the type of registration providers in this fashion allows for new, unknown registration providers to be created, as long as they implement the iRegistration provider and the iConfigurable interfaces and their assemblies are accessible. The custom configuration file also defines component designation and component name items. These items facilitate the discovery of services on a network, in this case, anyone looking for a registration service. The file registration provider and the SQLite database registration provider packages contain the required assemblies needed to perform their work. This includes the assembly containing the custom registration code, any other custom assemblies, the dodSON Core assembly, and the registration shared assembly, which contains the iRegistration provider interface required to be a registration provider. Looking at the custom configuration file for the registration relay bridge, we can see that it defines two clients: an external client that connects to the relay server and an internal client that connects to the registration server's communication controller. The note server and the RESTful service server both contain similar custom configuration files for their bridges. See the Programming with the dodSON Core Networking Namespace video and the dodSON Core Library Help file for more information about networking and bridges. Looking at the custom configuration file for the note service, we can see that it defines a notes provider group item. This item defines which group below will be instantiated and used as the note data source. There are two services provided: a file notes provider, which stores notes in a comma-separated values file, and an SQLite database notes provider, which stores notes in an SQLite database. Being able to define and instantiate the type of notes provider in this fashion allows for new, unknown note providers to be created, as long as they implement the iNotes provider and the iConfigurable interfaces and their assemblies are accessible. The file notes provider and the SQLite database note provider packages contain the required assemblies needed to perform their work. This includes the assemblies containing the custom notes code, any other custom assemblies, the dodSON Core assembly, and the notes shared assembly, which contains the iNotes provider interface required to be a notes provider. The custom configuration file also defines component designation and component name items. These items facilitate the discovery of services on the network, in this case, anyone looking for a notes service. It also defines search component designations and search component name items. These define the services which the notes service depends. The search component designation registration service is what will be broadcast for, and it should receive responses from both registration services on the network. The search component names defines the preferred services in order and by name that the notes service requires. In this case, it will attempt to use the cached registration service first. If that service was not found, it will attempt to use the registration service. The note server also includes a cached registration service. The cached registration service caches user security information in memory for a configurable amount of time. It cuts down on the network traffic created by the continuous user security verification requirements of the note service. Looking at the cached registration service custom configuration file, we see that it defines component designation and component name item. These items facilitate the discovery of services on the network. It defines itself as a registration service with the name cached registration service. It also defines search component designation and search component names item. These define the services which the cached registration service depends. Looking at the custom configuration file for the RESTful Note service, it defines search component designation and search component names items. These define the services which the RESTful Note service depends. In this case, a note service. The remainder of the configuration file contains the IP address, port, and service name used to connect to the RESTful service, the login evidence required to gain access to the RESTful service, and the encryption information used to communicate to the RESTful service. Now we will start all the servers and look at their initial logs. As each server is started, we can see the servers connecting to the relay server using its configurable bridge. The relay server log shows the relay server's component manager being started. The component manager then starts the communication controller, the installer, and the component controller. We can see here that it has started a TCP communication channel to allow the other servers to communicate regardless of their location on the network. The relay server does not have any components, therefore it does not install any packages, nor does it start any components. It is important to remember that the relay server's only purpose is to serve as the hub of a star network, allowing all other servers to communicate. The registration server has created several logs with the use of a log splitter. Looking at the system log, we can see the registration service starting. It first starts its communication controller, creating a named pipe server so its components can communicate with each other. It then starts the installer. First, it installs the registration relay bridge, which facilitates communication between the registration server and the relay server. Then it installs the registration service. The registration service has a dependency on the file registration provider and the SQLite database registration provider packages, which are also installed. Next, it starts the component controller, which first starts the registration relay bridge. It then starts the registration service. Once the components are started, this completes the initialization and starting of the component manager. The component manager is now running. The note server has created several logs with the use of a log splitter. Looking at the system log, we can see the note service starting. It first starts its communication controller, creating a named pipe server so its components can communicate with each other. It then starts the installer. First, it installs the notes relay bridge, which facilitates communication between the note server and the relay server. Then it installs the cached registration service, and finally, it installs the note service. The note service has a dependency on the file notes provider and the SQLite database notes provider packages, which are also installed. Next, it starts the component controller, which first starts the notes relay bridge and then starts the cache registration service, and finally the notes service. Once the components are started, this completes the initialization and starting of the component manager. The component manager is now running. The RESTful Notes server has created several logs with the use of a log splitter. Looking at the system log, we can see the RESTful Note service starting. It first starts its communication controller, creating a named pipe server so its components can communicate with each other. It then starts the installer. First, it installs the RESTful Note Service Relay Bridge, which facilitates communication between the RESTful Note server and the relay server. Then it installs the RESTful Note service. Next, it starts the component controller, which first starts the RESTful Note Service Relay Bridge and then starts the RESTful Note service. Once the components are started, this completes the initialization and starting of the component manager. The component manager is now running. Now that all the servers and their services have been started, let's go look at the services logs. We will start with the registration server service log. We can see that the plugin component registration relay bridge has been started and has connected its internal and external clients to the proper communication buses. Next, we can see the plugin component registration service starting. It logs that it has started the file registration provider and displays its component designation and component name values, and then it logs that it has started. We can see that it received supports component designation requests from both the cache registration service and the notes service. Looking at the Notes Server service log, we can see that the plugin component Notes Relay Bridge has been started and has connected its internal and external clients to the proper communication buses. Next, we can see the plugin component Cache Registration Service starting. It logs some warnings about minimum values being too low and being set to their default values, and then displays its component designation and component name values. Next, it logs that it is broadcasting a component designation search for a registration service, and then logs that the component designation search was successful. It found a registration service called Registration Service that completes the startup for the cache registration service. Next, we see the plugin component note service starting. It logs that it has started the file notes provider and logs some warnings about minimum values being too low and being set to their default values. It displays its component designation and component name values and then broadcasts a component designation search for a registration service. We can see a log here from the cached registration service indicating that it received a supports component designation request. Finally, the note service logs that the component designation search was successful and it found a registration service called Cached Registration Service. That completes the startup for the Notes service. Next, we can see a Supports Component Designation request was received from the RESTful Notes service. Finally, looking at the RESTful Notes service server services log, we can see that the plugin component RESTful Notes Service Relay Bridge has been started and has connected its internal and external clients to the proper communication buses. Next, we see the plugin component RESTful Notes Service starting. It logs some warnings about minimum values being too low and being set to their default values. It then broadcasts a component designation search for a notes service and then logs that the component designation search was successful. It found a note service called Note Service. Finally, it logs that it has created and opened the RESTful Services HTTP channel and displays the URI. That completes the startup for the cache registration service. These logs show that the servers have started their respective services and the services have discovered the services on the network that they depend upon. Download the dodSON software distributed programming framework example code and help file to learn more and view the example code, packages, and configuration files in detail.